to the Thoughtful Software Podcast with your hosts, Andrew Wolf and Fahad Shokat. Thoughtful software is a set of values, principles, and techniques to fuel digital innovation. We want to help usher in a new approach to the way software is imagined, designed, and built. Today's guest is machine learning expert Luis Serrano. Luis has a passion for teaching and is the author of Grokking Machine Learning. He is currently a researcher at Zapata Computing working on quantum computing. This episode covers a wide variety of information centered around machine learning, AI, applications for machine learning, and why everyone should learn machine learning. We hope you enjoyed this episode. Here is Luis and Fahad.
Luis, it's wonderful to have you on. I really enjoyed reading your book, and we'll get into that as well. I was just talking to somebody the other day, and they're starting a startup, and they mentioned 1,000 different buzzwords like machine learning and blockchain and so forth. And I'm really excited to talk to you about learning more about what is machine learning and what it isn't, and what are some interesting applications. And I think you'd be a wonderful person to talk to about that. I'd love to get an intro of yourself and some background and why you decided to write the book.
Yes, that's a great question. So I actually started not as a machine learning professional in my life. I started as a mathematician. So I did a PhD in math, and I was working in research and as an instructor in a university. And then I started hearing the buzzword like you mentioned, and I got more into technology, programming, and things like that. And so I decided to do a switch and move to Silicon Valley, and I started working at Google as a machine learning engineer. I was in the YouTube recommendations team, so recommending videos. When you go onto the page and it recommends a lot of videos to you, that's what we're doing, and that's where I learned. And I wanted to combine my love for sort of academia and teaching and math and my love for technology and machine learning. And so, in particular, I miss the teaching a lot. That's what I really missed. So I decided to move into a role where I taught. And so I moved to Udacity. I was teaching and directing the courses, the online courses for machine learning, AI, deep learning, all that kind of stuff. That's when I really got into that sort of education AI space. Then I continued at Apple doing the same thing. I was working there as an instructor, making courses in online and in person. And I've just always enjoyed teaching, and I like to combine the math with the machine learning. So I like to really see it and break it down into the basics, remove the formulas, and really capture the soul of the algorithms and the methods. And so that's why I started with the book, because I thought, okay, I have a YouTube channel and I put a lot of videos, and people get more engaged if they take a book and write things down as you go and do exercises and code as you go. So that's how we decided to start writing a book, and it's been a lot of fun ever since.
Yeah, I found you have a very interesting take on machine learning, this particular topic. So how would you define machine learning?
Yeah, so I like to define it as common sense for a computer. So in the following way, previously computers, you would just program them and give them instructions and tell them exactly what to do. If this, then that. But that's not how humans think. We don't take kids and give them a manual of life and then send them to live. We make them make mistakes, and we make them try things, and we end up learning by experience. And many times the decisions we make are by experience. If something happened to me several times, I assume that it's going to happen again or not. And in computers, that's called data. Experience is called data. It's what computers record. And so machine learning is a way to make computers think in that way, to make them make decisions, not based necessarily on a rationale or on instructions that we give them, but on experience. So that's why I call it common sense for a computer.
Where do you think machine learning comes into play that are similar tasks that humans might perform?
Yeah, pretty much everywhere. I think anywhere where there is repetition, you can do machine learning. So things like, for example, medicine, right? Like doctors looking at scans and deciding if the patient has cancer or not, like that. We can get a computer to aid the doctor to do that, right? To predict if the patient has a certain thing based on the scan or based on the symptoms. Make computers drive cars, which is something that we do repetitively, right? Basically, any task, I believe, that is repetitive can be done. Analyzing language, looking at images, everything.
Yeah, I think it's fascinating too, because one interesting point you made in the book is you call machine learning the new renaissance. And I mean, if you could elaborate on that, because it's not about replacing humans, it's about, allowing humans to become experts.
Exactly. It's about enhancing us in the same way that machines in the Industrial Revolution helped us, and they helped a farmer instead of feeding, four families with the work of a day to feed 100. In the same way, now we can have someone filling an accountant can do taxes for way more people with the help of AI. So the reason I call machine learning the new renaissance is because I have seen that the things are repeating. So in the Renaissance, you could be an expert in many things. You could have a doctor that was also a scientist and a painter, and then things got so specialized that it's hard to do that. You can only be an expert in one thing. But AI helps us so much in many ways that you see people that are experts in machine learning make advances, as I said, in science, in medicine, in art. So in that way, it's sort of giving us that renaissance person again. And the other way I also think machine learning is a new renaissance is because now computers are able to do that, right? Like what happened in the Renaissance? In some way, humans advanced their level. They were able to do mechanical things or things that are like answering questions or doing tasks or things like that. But the Renaissance was that boom of where humans started creating, when they started writing philosophy, when they started making paintings and art and science and all these things. And I think right now computers are sort of making that, bridging that gap, because machine learning has started as something where a computer can answer a question by looking at many questions, answer true false questions, or answer questions that require us the answer is a number, or making a task to pick up a box and put it there for a robot, or things like that. But now with the rise of unsupervised learning, computers are actually creating things. So they are painting pictures of faces that have never been seen before, that don't exist. They are creating music, creating writing. So I would envision that maybe one day they would be able to write, make sense of the world. So so I think it's definitely that stage of creation that is thriving right now, and that's why I call it the new renaissance.
Why would we want a machine to paint a painting or create music? What's the benefit of that?
Yeah, well, benefits and applications always come later, so I think they will be found, and sort of like industry will find a way to make that applicable. But as of right now, I just see it as a huge step, because the difference between answering a question and creating is huge, right? The difference between looking at a picture of a dog and saying, yes, this is a dog, or no, it's a cat. That's discriminative machine learning or predictive machine learning. But creative machine learning is able to say, you write, paint a dog, and it just paints a dog. So to me, that is a whole new level of intelligence for a computer. So yeah, I don't know the applications, and I think they will come, but to me it's just a huge step.
Yeah, I could probably see that if you're able to create music, maybe it's related. That function of creating music could be applicable somewhere else, because there'll be a lot of interesting technology just to create like a nice musical score. Maybe it could be related to, you know, soothing some sort of disease, or just like how music plays into calming people down. So I think that, yeah, you're right. Maybe there's some applications that we don't know about yet.
Exactly. And then for us, it will maybe make us go on a higher level of mind, right? It would say, okay, well, now we think what makes us human, the fact that we create these things. Now the computers can create these things. What makes us human? And then we will go on a higher level and discover maybe more things we can do.
I think we should also distinguish too, like machine learning is AI, but where does machine learning fit into this? Is AI the umbrella, and where is deep learning and all these? Where do they all fit in?
Yeah, that's a great question. And the idea is that AI is the encompassing one. AI is the big one. And every time that a computer uses some kind of intelligence and makes some decision, that's called AI. Now, there's many ways this can happen. Some of them can be using logic and reasoning. You can program the computer to do a certain task, or you can look at the rules of a game. And others can be using data. So when it's data, then it's called machine learning. So basically, the difference is when a human is making a decision based on rationale. Think, okay, if I do this, then this may happen. That's AI. And if a human is making a decision out of experience, then that's machine learning. And then deep learning is an area of machine learning where you are using one particular algorithm, one particular model, which is neural networks. So basically, AI is big, then inside it's machine learning, and inside it's deep learning.
Yeah, I find that interesting. So in your book, you have a lot of these interesting quotes and things that I just found fascinating, like the Renaissance. But the other thing that you mentioned was what is needed to understand machine learning is a visual mind. What do you mean by that?
Yes, definitely. I appreciate a visual mind more than I appreciate math, and or well, not math, but formulas. I think math is more visual and conceptual than it is formulas. So I'll give you an example. Regression, right? I talked about that in chapter 3. It's really just you have a bunch of points in the plane that look like they're close to a line, and trying to draw the line that goes the closest to all of them. And so if you think about it mathematically, you say, okay, well, I'm going to draw a line and then measure the distances to the points and square them and add them and take the derivative. And then you do some kind of gradient descent to decrease that error, et cetera, et cetera, et cetera. But that's not it, right? What's really happening is that you're trying to make a line go close to some points. So you just look at one of the points and make the line and move the line closer to it. And you continue in this fashion. And that's something that I can explain to a child, right? I can tell the child, hey, look, there are some marbles in the floor, and you have this long rod, and you wanna make it close and close to the points. So that to me is the concept behind the formula. So if anybody understands geometry like lines and points moving around, and even things like the concepts of probability, but not with formulas, but like what things are likely to happen, etc. To me, that means a lot more than looking at formulas.
Yeah, that's really fascinating in connecting something that, visually we can all understand to something that could be very complicated. And you've mentioned also you embarked on a journey to understand the melody of machine learning. And I found that really fascinating. And if you could explain that, that'd be great.
Yeah, absolutely. I always look at music because I think they figured it out. I think they explain things better than we do in STEM. Because in music, for example, I can appreciate a melody. I can listen to Beethoven's Ninth and completely appreciate it and fall in love with it, and look at the magic behind that without knowing anything about scales, without knowing anything about musical theory. I can appreciate it. And of course, if I want to compose something like that, I have to study for years. And if I want to play it, I also have to study for years. But I can appreciate it. And I want to have that in mathematics and in machine learning and in physics and in science, because we don't have that. A person who doesn't know a lot of math cannot fully appreciate a math theorem, an advanced math theorem. Maybe some exceptions, but the majority you can't. And I wonder why that is. And I think it's because we haven't done a great job explaining them. I think when we talk about mathematics, AI, all these fields, we just go straight to the formulas, and which is the same as if I were to show you a great song, but instead of playing it for you, I just give you a page with notes, a page of scales and treble clefs and bass clefs and stuff like that. That make no sense, right? So I try to play the
Right.
music of mathematics and show you something that everybody will appreciate without having to know any deep knowledge. And of course, if they want to create things like that, they would have to study math to understand it, but something that people can appreciate. And so that's what I mean by the music of mathematics, and that's what I do in this book. I try to play the theorems of the algorithms in a way that people can look at them and appreciate them, sort of hiding the. I still have the formulas, but I have them later. But I try to
Yeah,
really show the concepts.
that's fascinating. I really love that. So if you're an enterprise, let's move to, we understand machine learning is important and there's a lot to it. But if you're an enterprise and you're listening to this and you're thinking about um, the new more like emerging technology or just the next generation of applications and technology to apply into your organization and how it's going to help your business. What are some simple applications that you would recommend enterprises could, get started on?
Yeah, I mean, I think going AI right now is a no-brainer. It's like asking 20 years ago if they should start using computers or if they should start using the internet. Definitely, I think everything will have AI uh, pretty soon. So it's almost a requirement. A business that doesn't go into AI will most likely not survive the next generation. As for what applications there are, pretty much anything. I would recommend enterprises to look into what they do and see. You can look at bottlenecks. You can look at the things that they would like to automatize. If they have, for example, a web page, they can do recommendations for users. If they sell things, if they use language that you can use, for example, if you interact with clients, you can use natural language processing to understand the language and to get trends on the text, the conversations you have with clients or in reviews. If you deal with anything related to images, you can use image recognition. If you So basically, it's everywhere, and I would just recommend businesses to start looking at where is the repetitive part of their business that they can start applying machine learning on.
I've seen some companies that have, identified this as something very important, and then they go down this route of, you know, putting together a large budget to build a data science team. And, obviously, data scientists are really expensive. And then 9 months later, you don't necessarily have the results that you're looking for. So that's an issue in itself. We will maybe touch that later. But what you're kind of talking about is organizations have a lot of data, and I
Yeah.
think for machine learning, that's the heart of everything. So let's talk about maybe some steps that enterprises could kind of get to. Number one is how do you clean the data, and how do you look at the data and make sure that it makes sense? Do you need an army of data scientists, or could you kind of slow started?
No, that's a great question, and yes, definitely the first step that companies should do, as you mentioned, is put their data, like organize their data. Because in the worst case, even if they don't find any great applications for what they do, or even if they don't see any results in a year or something, just putting your data and organizing it and having pipelines for your data will make sure that whenever you figure out the model or the applications, you have lots of data to feed it in. As for cleaning up the data, yeah, that's I would say the arguably what a data scientist does the most, because there are some very pretty models, but those are just always one line of code. What the data scientist does is go into the data and clean it. So some steps to clean up data is understanding how a model receives the data. So I always tell people, when you're trying to imagine how a model brings in data, imagine that the model takes an Excel spreadsheet. Okay. So if your data looks like an Excel spreadsheet, then you are ready for a model. And that sounds easy, but many times data doesn't come like that, right? If your data is images, how do you put that into an Excel spreadsheet? Well, you just have to take the value at every pixel and put them in a long row, and depending on the color. If your data looks like sound, how do you turn that into a row in an Excel spreadsheet? That's hard. So you have to really think of how would you put your data into rows and columns. Then I would say you can. There's always going to be outliers. There's always going to be some points that will mess up your model. If you're doing a model on house prices and you manage to predict the price of a house, and then turns out there's like a really expensive house in the market, then that messes up your average, right? So that would also mess up your models. Or if you're looking at salaries in a company and then the CEO is just way off, then that messes up your model. So you always want to remove those outliers, recognize them and remove them. And for that, you need to really know your data. Then you would also need to fill in missing data, right? If you have data, doesn't come very pretty, especially if it just comes from nature, well, not from nature, but from like real life happening in your company, and then you're trying to record this data, there's always going to be missing values, missing data. And the question is, how do you fill it in, right? Do you fill missing values if many users are missing their age or their gender, or their many things are missing the price, or things like that? How do you fill it in? With the average, with the most common label? You make a new label with the ones that are unlabeled, or you manually? Like that's a question that is different for every business case that you're having. And so that's why it's important to have good data scientists in the team that will know data science well, and that will also know the actual problem you're trying to solve, because it's different in every scenario.
What do you think of some of these companies that are, you kind of plug in your data and it cleans it up for you? Have you found success in those in those companies with those?
That's a great question. Well, I haven't used them myself personally. I think they probably provide a lot of value because they know. I would still say you still need to do some cleaning yourself, because only you know your own business case. You can get help if there's companies that will clean it up for you. Then if they work together with your company, then I think that's a good idea, because I think definitely knowing your use case is very important. If I can have if you give me a data set, I can treat it the same way as I treat another data set, but they may have completely different problems underneath. So definitely working with the client is important. There's also some that actually create some data. So here's something interesting. Let's say you have images, and your app or what you do is uses images to train the model, but they're very hard to find, and you only have 10. But obviously 10 doesn't do it for a model. There are companies that actually create data for you. They create images. They sort of they create mimic data that looks a lot like your data. And I think that's pretty useful too, because gathering data is a huge problem, and many times you just don't have enough data to build something good.
Yeah, fascinating. Well, one thing we've talked about before in this podcast, and it comes up in almost every machine learning project that we have, is biases in the data.
Mhm.
And you said, that most data right now is biased, and I
Yep.
100% agree. I don't think people quite realize that, and you see this in the news. If you've ever wondered, like Apple Card, a lot of credit card companies will, automatically deny
Mhm.
certain people, and
Yep.
it just happens, and so how do you actually, I mean, we are aware of it, but how do you actually remove biases from the data, from data? Is it possible?
Yeah, that's a great question, and that's something that's of utmost important. Obviously, humans, we have flaws, and flawed humans have made the decisions all the in all our history, and then we collect that data and we ask a computer, "Can you repeat what we've been doing?" Well, then obviously the computer is going to have those same flaws, right? It will be racist, it will be sexist, it will have many of the biases that we've had historically. So the first step is what you're doing, which is being aware of it. I think that's huge. Always be aware of it, and always try to solve it. At the same time, we have a lot of blind spots. Like this is it's not something we just decide to say, okay, I'm gonna be proactive. It's a skill, right? We have to look at all the blind spots. And in my experience, the only way to see blind spots is to have diverse teams, or the most important way. If we have a team that is very homogeneous, that everybody has the same gender and race and nationality and age, it's very hard to see some blind spots, right? I used to work in a recommendation team, and what we did was we first tried on ourselves. Like I would just make a model, and I would look at how it looks for me, and if it looks good, then I try it with the population. But that's a humongous bias. That's a humongous blind spot right there. And so teams need to be diverse. We need to have as much diversity as possible in the people working in data science problems. And then one step further is to actually be active in collecting good data sets. If you are going to train a model with a data set of faces or of text or of hands, like they're all taken from similar sets of people. So there is actually research going on in collecting and curating good data sets, and that's I think would be like a much more elaborate, a much more thorough approach.
No, cool. Okay, I find that fascinating because I don't. I think you're right. It's more accepting that humans are flawed rather than being perfect. Because I don't think it's going to get there anytime soon. Let's talk about some applications. Like one I'm always fascinated by is around sentiment analysis,
Hmm.
and a lot of companies would find this very valuable. You see, companies like McDonald's and consumer brands trying to scrape social media to understand how people feel about their brand, or, did they enjoy this hamburger? And where is sentiment analysis now? How accurate is it, and how, useful it is for organizations, whether you're in consumer or like enterprise? Where does it stand now?
Yeah, no, sentiment analysis is definitely one of the most important applications right now. And luckily, it's among the natural language processing techniques, I would say one of the easiest ones. And the reason is because you're just training a computer to read and answer questions. You're not training it to talk. That'll be hard, right? So sentiment analysis consists on, you give the computer a sentence or a paragraph, and then you ask it, is it happy or not, or any question you want. Is it spam or not, or is it about this or about that? And that's basically sentiment analysis. So you ask it the question that you train it to answer, and it's in a pretty good state. I think the algorithms, the most common algorithms of machine learning give you pretty good sentiment analysis models with good accuracy. And if you want to go a little further, you can do things like recurrent neural networks or LSTMs that actually go a little further and analyze, the structure of the language a little further. So it's definitely at a good spot. I mean, you can always get better, but it's at a good spot. Once you're talking about a chatbot or something that talks back to you, or something that's more complicated. But sentiment analysis is pretty useful and pretty good right now.
So here's another use case for machine learning. One of the problems I have with the internet in general is when you read an article, and let's say machine learning, and I've read thousands of articles on machine learning, and I'm pretty well versed. Now, when
Hmm.
I try to look for something else, it's very hard to find that expert article.
Yeah.
Can machine learning help me decide, like, okay, here's all my document data stored, show me only the expert articles. I don't want to see the beginner level articles. Is that a useful application, or is that
That's
possible?
interesting. Yeah, that's definitely a useful application. That I would say, yeah, it's a little slightly harder than if you ask it, show me articles about this field. Is simpler than if I say show me the expert articles. But if you train it properly, it's not. Yeah, I think it's doable to make a model that shows you the expert articles.
Oh, interesting.
Yeah.
Let's talk about another one that I think most people run into, whether they know it or not, are recommendation engines, like
Oh yeah.
Netflix and music, you name it. Uh, Explain how that works, and how a recommendation engine works, and where a machine learning comes in.
Yeah, definitely. Recommendation engines is one of my favorite applications of machine learning, and well, I worked on it, so I enjoy it, and also because it pretty much uses all the techniques imaginable. Like there, kind of everything goes with recommendation engines. So, for example, classification, which is answering a yes no question, you can train a model to determine if a customer is going to buy something or not, or if it's going to click on something or not, or read something, or watch, or listen a song. So that's sort of the quintessential recommendation engine. It's a classification model. And then you can also use regression. Regression answers a question with a number, right? So it says, you can ask, how long is this user going to watch this video? Or how long is they going to listen to the song? Or how much will they spend if they go to my website, etc. And then you can go into other things like unsupervised learning. So you can do things like clustering. Clustering is mostly grouping points into points that are similar. So for example, I can group customers and say, for example, let's say you are very similar to someone else based on your demographics and your clicking patterns or your buying patterns or just anything. And so whatever they did, I will recommend to you. So that's a simple application. And you can also group things, right? You can group objects. When you go to Amazon and it says customers who bought this also bought this and that and that, right? It's grouping them. So if you buy a certain object that is similar to another object, it's just going to recommend you that other object. And then you can even go one level deeper. It's one of my favorite models is matrix factorization, because let's think about this. Clustering tells you when humans are similar. So for example, I would say I figured out with a model that you are very similar to your brother, for example. And so whatever they buy, I recommend to you. But what if, let's say, you are not very similar to your parents, but you're a lot like their average? For example, if your dad gave something 5 stars and your mom gave something 3 stars, you're very likely to give it 4. Right? Like, that's not clustering, because I'm not joining you in a group with people, but I'm actually making mathematical relations between people. I'm saying this person is the average of these two, or this person is 30% of this one plus 70% of that kind of stuff. For obviously not all the time, but for the most part, you can sometimes predict people's behavior by doing this kind of mathematical relations. And so that matrix factorization and is sort of another thing that's used for recommendations. You can always use more things in recommendations, but those are some ideas.
What I find interesting about matrix factorization is, or just machine learning in general and recommendation engines, is around creating a bubble, and what you may see as opposed to getting cross views and other types of information. And I find that really interesting.
Yeah, no, I think that's a potential for a huge problem, because of course people now, there's a lot more news than before, but people have a lot more choices and they would always just choose what they know, and then people just they reinforce their biases and they end up sort of confirming the things they believe, because there's always some news about the things you already believe. So I think it's necessary to be much wider. And just as people, this is not a machine learning problem, but we should read things that challenge us and try not to get siloed and try not to get into that bubble. As for machine learning, that's a hard problem, right? Because machine learning is trained to try to recommend you the news that you're most likely to look at, or the music that you're most likely to listen, or the movies that you're most likely to watch. And what about serendipity, right? What about that movie that somebody told you that you never thought you would like, and you watched it and loved it and found out a new part of yourself you didn't know? So how do you do that? And that's a very hard problem for machine learning models. A solution that I can think of is the simplest thing, which is put random stuff. Like, if I'm going to recommend you a bunch of songs, I will just throw a couple of random ones here and there and see how you react to those. And if you click on them, then it means you're allowing the model to sort of explore the space more. So yeah, it's a hard problem, and mostly heuristics are what helps. But it'd be nice to have a machine learning answer to that.
Okay, well, that's interesting. So I want to discuss one article that I read just 2 days ago. It's about a company. I don't know if you read about this, Starsky Robotics. It's an autonomous trucking company, and they actually are folding. They're closing up shop, and they had this really interesting retro of some of the issues that they ran into and why the company failed. And
Mhm.
one of the things that came out of this, and I found it really fascinating, is I quote this and it says, "The biggest, however, is that supervised machine learning didn't live up to the hype. It isn't actually artificial intelligence akin to C3PO. It's a sophisticated pattern matching tool." I'm just curious, like, what do you think happened there? Like, why didn't supervised machine learning, like especially in like autonomous cars, why is it not living up to the hype? What are some of the challenges there?
Ah, that's interesting. Well, yeah, in autonomous cars, you need a lot more than supervised machine learning. You need most of the applications of machine learning are a patch of many things. So you use supervised machine learning to say determine if a pedestrian is in front of you, or to determine where you are, things like that. But the really the key to everything is combining the models properly. And so I'm not sure exactly what happened in their case, but you also have to deal with how your errors are, because machine learning models are not um flawless. They will always have a lot of mistakes, and we need to treat those mistakes differently, right? If a self-driving car makes a mistake, or if a medical application makes a mistake, it's much more expensive than if a recommendation engine makes a mistake, because those are okay, right? So the treatment of the errors is always very important.
Yeah.
But yeah, I'd be interested in what happened.
Yeah, I'll send you the
What
article,
happened
but
to
I
them?
think it was really
Yeah, please.
interesting. It was interesting to think about like expectations, right? And their biggest comment there was that it didn't live up to the hype. And
Mm,
his comment there was that autonomous cars, fully autonomous cars, are about 10 years away. They're not actually close as we think they are. And I thought that,
hmm
like, so if you have a machine learning project, and trying to understand and calibrating your expectations. So, like, if you're aggregating all these different data sources, what is it that you're trying to get out of it? If it's like this fully autonomous,
yeah,
trucking company, there's more things than just data. There's, politics. There's, I mean,
yeah,
there's all
exactly.
kinds of things that are going on. And so just set your expectations.
Yeah, you need to pick your battles, because yeah, sometimes maybe you cannot have a fully autonomous truck right now, but you could have a semi-autonomous, or something you can handle partly, and then be ahead of the game, so that when the actual technology is for fully self-driving cars, you're already there,
Yeah.
right? So we need to pick our battles.
Yeah, absolutely. That's cool. So as we wrap up, one thing I'd love to learn from you or hear from you is, where's machine learning going? And we're recording this on March 26th on Thursday in the heart of this COVID crisis. And so there's, things where machine learning is helping with, vaccines, all this modeling that people are doing,
Yeah.
which I find fascinating. But where else, do you think machine learning is going?
Yeah, no, I think you mentioned it very well, that it's being used a lot in this coronavirus thing, and I think a lot of it is where we use it. The algorithms are very classical. Most of them have been around for a long time, and so it's all about how we use them, right? As computers get faster, as we have more data, the questions that we're able to answer are more and more with the same simple algorithms, right? So things that are being done in coronavirus, for example, they're predicting the structure of proteins, or predicting the spread of the virus among the population, or even looking at images. They look at scans of people's x-rays and things like that, and try to predict it from there. So they're doing a lot of great applications, which are known methods, yet they are new applications. So one way machine learning is still growing, it's on the breadth of the applications. And as I mentioned before, definitely creative machine learning is on the rise. I mean, now that when we start finding applications to all this, the deep fakes, and the creative, creating faces, paintings, things like that, I think that's sort of the next round for machine learning. And another thing that I've been interested lately, that I think is the next step is also quantum AI. I think once we get quantum computers to work, they're sort of a next step for AI.
One last point is I think we've talked a lot about machine learning and all kinds of different applications. It's going to be everywhere. And you believe that it should be basically it's going to become mandatory, and it's not just
Yes,
there's technical skills to it, but then everyone should understand what is machine learning.
absolutely. Yeah, this is as mandatory as buying a computer became a few years ago. Like, this is for companies, they pretty much have to go into AI. But the great news is that AI is such a broad field that everybody can go through it based on their strengths and what they want to get out of it. Not everybody needs to learn how to program AI models. This is just for the data scientists and the software engineers, right? Someone like a CEO, as you mentioned, they're not going to write code, but they need to know how to make decisions with AI. So the concepts of AI are very important. So people like product managers, the decision makers, everybody, they need to learn these so that when they talk to their data scientists, they know what's happening, and they can make those decisions. So I think pretty much everybody can, and everybody should learn what they need of AI and use them to use their strengths to to improve it, and to have it improve their lives.
Luis, it was fascinating talking to you. Thank you so much. Maybe you could share with us where people can learn more about you, learn more about machine learning, get your book. Would love to learn that.
Yeah, thank you very much. I had a great time talking to you as well, and the questions were great. In order to find the book, click on the link on this podcast, and it's there. Also, a great place to find all my information. So I have the videos from the YouTube channel, and the book, and some writings is on my page, which is serrano.academy, and it's also linked in my bio.
Thanks for listening. You can always connect with us at skiplist.com.